Again, the first one is going to be our easy one. It is an easy difference of squares. Because it's obvious that the first term is a perfect square because it's a times a. And it's obvious the last one's a perfect square because it's b times b. And anytime you have a perfect difference of squares, you can set up your brackets. A times a, b times b. One of them will be positive, one will be negative. And when you multiply this out, do the first ones give me a squared? Yes. Do my last ones give me negative b squared? Yes. Do my outside and inside cancel out? Negative ab on the outside, positive ab on the inside? Yes. Okay. Now, if you want to use the substitution, you can. But this time you're going to use two different letters. Okay? You could let p equal 3x plus 4 and q equal 2y minus 1. And then you would just have p squared minus q squared. I do find with these ones, if you recognize that this is something squared minus something else squared, that a lot of people can go right away to the two sets of brackets. My first one was 3x plus 4 and 3x plus 4. My second one is 2y minus 1 and 2y minus 1. And one will be plus and one will be minus. Some people are able to go to that directly, and then you don't have to do the substitution. I never finished the substitution. What would you like to do next? Would you like to finish the right side first or the left side first? Okay, we'll finish the left first. If you use substitution, then for factoring this, it will be easy because it's just p and p, q and q. One will be plus, one will be minus. And then you would have to substitute back. And once you substitute back, you will get exactly what we have on the left side. 3x plus 4 and 3x plus 4. Notice when I substitute back, I use brackets to plug it in. And 2y minus 1 and 2y minus 1. As I substitute the p's back in for the p's, the q's back in for the q's. And in my first big set of brackets, can you see that I have a 3x, a plus 2y, but I do have some like terms because I have a 4 and a minus 1. Those put together will just become plus 3. In my second set, I have a 3x. This will be a minus 2y. And the 4 minus a negative 1, those are like terms. That becomes plus 5.
Wouldn't your first term in the first bracket be 6? Oh, no, because you can't combine.
Perfect. So that would be the final thing. If you didn't use substitution and you did, you'll notice that these two are exactly the same, right? It saves you a little bit of work if you can see it right away as a difference of squares. And then on the right side, you would go to the next step, which would give you exactly the same answer because you combine your like terms. And so they become the same that way. Okay? For part C, you can see that maybe you would let p equal the 2x minus 3 and q equal the y minus 4. you might go to that right away and use substitution. If you wanted to do it directly, to see could I do this directly, you see the minus sign. Are both of these perfect squares? Well, 27 isn't, and neither is 75. But there might be a common factor that you could pull out. So why don't we, because you can't do it directly, this is often a place where it makes sense to use a substitution. So I'm going to start by making p 2x minus 3 and q y minus 4, just so that we change our expression to something that looks simpler. So at this point, it looks simpler. But again, I can't factor this. Whoa, where'd the 3 come from? Sorry about that, guys. There's a 2. So at this point, I think difference of squares, because I've got the difference, and I've got squares on both sides, but my 27 and my 75 aren't perfect squares. And I take a step back and I say, is there a common factor that I could pull out of the 27 and the 75? 3. So I pull that out, leaving me with 9p squared minus 25q squared. And again, I think difference of squares inside my brackets. But now are the 9 and 25 both perfect squares? Yep. Yes. So bracket, 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 and we'd have 3p and 3p, 5q and 5q. 1 would be plus, 1 would be minus. And now that we have that, we could substitute back. P was 2x minus 3. Q was y minus 4. All right. You would have to multiply this through here, multiply this through here, simplify your like terms. Are you okay just to trust me that it's going to be 6x plus 5y minus 29? Well, I would do 6x minus 9, and then it would be 5y minus 20. And the minus 20 and the minus 9 are like terms, so they could be put together to get minus 29. I'll write it above. I would get 6x minus 9 plus 5y minus 20. Then this one and this one are like terms, so they become minus 29. Same thing over here. You're going to get 6x minus 9 minus 5y plus 20. And when you get all your like terms together, you get 6x minus 5y plus 11. For this one, if you didn't see it as a difference of squares and one where you would use substitution to begin with, you would not be able to solve it. So this is the only way to solve this one. Okay. 12, 13, and 14